Hi guys, please like, share and subscribe. And if you want full course for any actuarial subject, visit theactuarialguy.com or WhatsApp on this number. Thank you.
Hello and welcome guys. In this lecture we are going to start talking about R programming, right? So firstly I'll fundamentally introduce the idea of why do we want to study R within the actuarial curriculum, and then I'll get into how do you download R, how do you interact with it, what is it all about, all of those things, right? So let's dive right into it, right? So far whatever mathematics you have done till this point, it has been on pen and paper, right? So all of your complex computations, you were solving algebra on a piece of paper, right? But when you go to real world organizations, right, there you can't use pen and paper, you can't use your calculator, right? Because it's just not efficient. You're dealing with very large data sets, right? So eventually you have to use computer softwares to solve analytical, mathematical or data related problems, right? Now, one tool that we have within the actuarial curriculum is Microsoft Excel, which in itself is a very powerful tool, right? But that is a graphical user interface or a GUI tool, right? There also we have formulae and you write a bit of code, right? When you're writing if loops and all of that, right? If you have studied CM1 before that, you would know you write nested ifs there, which looks a lot like a piece of code, right? Or you're writing these long VLOOKUP formulae. So that feels like you're writing code, but at the end of the day, you can visualize the data in front of you. You can see it, right? You can manipulate it by using your mouse and copy it around, create tables, all of that, right? So that is a much more interactive sort of way of dealing with data, and that has its own merits, right? It's much more accessible to most people, right? But the time we live in today, right, even that method is not good enough because it doesn't have the flexibility that a coding based tool gives you, that a you know a command user interface tools gives you. What does command user interface mean? It means that you're interacting with the computer using lines of code, using commands, right? And that is where R comes in, right? So R is a language which is very, very specific to, you know, problems which are more in statistics, data analysis, so on and so forth. You also have wider tools, tools which are more general purpose, which can also be used to do data analysis as well as build software. Uh, Examples of those tools are Python, right? Python is a language which is much more general purpose than R. R is very, very specific to data analysis and statistics, and thus it will be very, very easy for us to learn as a first language. See, in programming, coding is essentially about two things, okay? One is the logic, second is the syntax, okay? The logic is what really matters, and that is common across languages, okay? The logic is all about thinking computationally, right? How do you take a real world problem and how do you write it in the language of a computer? How do you build the logic for a computer to be able to solve a real world problem, right? That building of logic is the primary basis for computer programming, right? The syntax with which you write it, that is secondary, and that differs from language to language, right? So once you are able to learn one language, once you learn R, right, learning Python, learning any other programming language won't take you a lot of time. It would just take you a couple of days, and now with AI you can actually learn it much faster because you don't need to write the syntax. If you are able to tell the logic to AI, it will be able to write the syntax, right? So learning your first programming language is actually the real challenge. After this, things would become much, much easier and you will be able to pick up any programming language, okay? Now with that, let's just get into R. Okay, now I want to start by talking about the tools that we have here, when we talk about R, so you have two pieces of software that you work with. Okay, what are these two pieces of software? One is R itself, which is the base engine, right? Which is what runs everything. Okay, so your code essentially runs on R, right? And that is all you need to run your code. But then R itself is not very user friendly. Okay, it's not a very efficient way to write code. So you need an IDE, which is an interactive development environment or a user friendly interface, that is called as your R Studio. Okay, so now to begin with, we would uh, install R and R Studio, right? Let's start there. Of course, you can just Google and install, but you need to see at this point uh, what is the version of R Studio and R which is allowed by IFOA. So you need to check IFOA or II if you're writing the II exam. Their handbook, you need to check that and see what is the versions that they are recommending and allowing. You should download those versions. You can just Google and download or use these links. These were links which were provided by Acted, so I'm going to use these links and show you. So this is your R's official website, in fact, which has opened, and it's opening as a subdomain of this stats.bris.ac.uk. Okay, yeah, so we'll download R from here. So what I'll download is R for Mac OS, and you can download R for Windows, right? If you have Windows. Yeah, so this is Apple Silicon M1, M2, so on and so forth. So I'll download this package, right? Yeah, essentially looks the same across Windows and Mac, and then just the way of installing must be slightly different. And this one is your R Studio. So this is your R Studio. I've come to pose it to download it. Okay. So download and install R Mac OS version, right? My version would be higher than 13. So download R Studio for Mac OS 13 plus, right? So these two I've downloaded. Now, once they get downloaded, I'll just install them. So that's the first thing. Okay, so one thing that I realized was that this link for downloading R itself was slightly slow. Okay, so you can also Google and download it. So I search for Project R and you get to the official website of Project R. You can also download it from here. You click here. Under download, it says CRAN. You click here and then you find the mirror for your country. So I have India here, right here, and then you can click this link to download. It will download slightly faster. Okay, so that is one advice. Now, okay, let's just install both of them. So now don't get confused with my installer because it would tend to look slightly different because this is Mac and you might have Windows. Okay, so now this is installing. I'll just use my password and it will just install the thing. Okay. And once R is installed, I will install R Studio as well. Okay, so this is closed. I'll just move this to trash and yeah, R Studio here. Okay, I just drag it to my application, just replace the existing installation that I have, and yep, R Studio is also done. Okay, so now R and R Studio both are installed. So now let me quickly show you what they look like. So R, Project R. So R Studio I can open directly, and I've told you this is a more user-friendly environment for writing R. But I also want to show you what the base R looks like, right? So that you know, like that one is not very friendly. So this is what your R Studio looks like. Okay, I have a bunch of things open here. I'm going to close that. So this is what your R Studio would look like. plain blank RStudio with nothing open. And if I open a new file, you have to open a R script. Okay. So this is your script. This is where we'll primarily be working. We'll be typing out our code, which would be the top left window. So you can write 2 plus 3 here, or whatever you want to write, 5 plus 6. And this, you can actually get the results of these. The way to get the result is to click this run button, and it will run these R, the base R working behind this. Which R is working behind this? 4.5.1. This is my version, right? So that R will work behind this RStudio to get me these results. So it says 2 plus 3 is 5, 5 plus 6 is 11, right? So it's working perfectly, right? This is my these are a certain set of tools that I have. This is where I'll be seeing all of my variables that I assign. We'll get to what variables are and all of that, right? So you have a bunch of options here: environment, history, connections. You have tutorials for R as well, so you can look at these. So yeah, so we have a bunch of things here. It's a screen which is divided into 4 parts. So yeah, we'll explore different parts of it. So this is your RStudio. This is what we'll be working with primarily, but you also have the base R. So let me show you that, right? Now, in order to show you that, I want to go to my applications and see where I can find the R. Okay, yeah, so I have RStudio and I have R. Let me show you R. This is my base R. See how simplistic this is. This is just the R console. This is just this part of R, right? If you see, this is where everything gets executed. This is called as the console. Console is where you put in your input and you directly get the output, right? So this console and this console that I'm getting is the same. So if you will just type 2 plus 3 here and press enter, you'll directly get your answer. See, it looks so similar. Here also you can just write 2 plus 3 and enter, right? So this is your console. This is your editor. This is where I will be building up an entire piece of code, right? Because we don't want to execute after every line. That is really inconvenient. If you want to do some quick calculations, obviously you can use this region, right? This console region, or open R directly, right? R console directly. But in most scenarios, what you want to do is you want to build a full length logic and then execute it together, right? For that, you will be using this text editor, right? So that is the idea. And this is your base R. So this RStudio is accessing this only. So you can see this, and then within R you can actually open a new document. Here you can write a script very similarly to this, right? So this also has an editor. So if I'll start writing 5 minus 4, 2 plus 3, and now in order to just make this functional, I actually need to put print around this. Otherwise the script would run with no result. To tell R to just show something, you need to also write print around it, right? So print 5 minus 4 should give us 1. To print 2 plus 3 should give us 5, right? Without the print, if I would have executed the script, it would have yielded empty. This is something again we'll get into later. Now what I want to do is I want to save this, right? So you can actually go to file and you can go to save as, and you can select the folder wherever you want to save, and then save it. Okay, so I am saving it within our programming lessons in my documents folder, and I'll just click save. Now once I close this and I want to run the script, what I'll do is I can click here, this button. This is to source a script or load data in R. This is only within R console. Or you can just go to file and you can click on source file. So either one of these two, you just click and then you select the script that you want to run or source, and when you do, you will get both of your answers, right? So 5 minus 4 is 1, 2 plus 3 is 5, right? So this is how you work with R console, right? But mostly we'll not be working with just R console. We'll actually be working with this, which is your R Studio, right? So that's all for the console. You don't need to know anything further about it. Of course, you can explore it and how graphs and everything are plotted here. It has its own interface, right? But it's not very user friendly, and for our purpose, what is more important is RStudio. Okay, so I'll close this now and I don't want to save anything. Okay, now let's come to RStudio. So within RStudio as well, you can actually open the same file that uh, you had seen uh, there, which you had created within our console, and this is that file. See, the same file has opened here, right? So the extension of the file which is uh, opened in RStudio or our console is .r, right? So remember that any file that you'll be saving, you should save it as .r. Okay, so that's the first thing. Now let's just try and interact a bit with this R Studio, this text editor, right? I've told you some functions, right? So there is a print function, there is addition. Similarly, you can divide, right? So 2 by 3, you can multiply 5 times 4, right? So all of these functions work in R. What you can do is just run them, or the shortcut for running everything is command enter or control enter in Windows. Okay, so as many times as I click control enter, if I just want to do 2 by 3, that is 0.6667, I'll just press control enter or command enter while selecting this. However many lines you want to run, you just select all of those lines and you press control enter or command enter, right? So you just get those all of those lines just get executed by the console. Now my console looks really messy. How do I clear it, right? How do I just empty the console? Because console has all the history of whatever command that I have run till this point, right? Like a whole bunch of things are there. So if I want to clear it, I do control L. So shortcut for this is same on Windows and Mac. For clearing, it's control L, not command L. It's control L on both Mac and Windows. So if I press control L, it just gets cleared, right? Also on Mac, in order to run or execute the lines of code, you can do control enter or command enter, both work, right? If you want to clear using the mouse, then you can also use this button. You see this broomstick button. So this broomstick, if you click, it is just clear console. So once you click it, the console clears, right? Now the next thing I want to talk about are the basic arithmetic functions. So we have already talked about some of them, but I want to discuss, we have discussed division, addition, subtraction, multiplication. Now maybe I can talk about exponent. So if you want to write exponent, okay, firstly, to write any comment, you can use this hash symbol. This hash symbol indicates that whatever you are writing is not a part of code, but it's a comment. Okay, so if I want to now start discussing exponent, there are two ways that you can actually write exponent. Method one is you use to the power symbol, right, raised to the power. So if you want to do, let's say, 3 to the power of 2, so this is how you can do it, right? And another method is you use 3 star star or asterisk asterisk and 2, right? So this is another way. Let me show you. Yeah, 3 star star. This is also a valid way to write exponent. So both of these methods are valid and will give you the same answer. Okay, so if I do a command enter, see, this is 9 and this is also 9, right? So this is how you do exponents. So all of these things we know. You can work with fractions as well. If you have spaces in the middle, right, that R completely ignores, so you don't need to worry a lot about them. So for example, if I put this into the R console, it will read it as -3 minus -5. Okay, what does that mean? -3 plus 5. Minus and minus would become plus, right? -1 is essentially multiplied here, so minus and minus will become plus, right? So -3 plus 5 would be 2. Okay, so if I check, this is 2. This is also correct, right? In order to execute, just select whatever you want to execute and do command enter or control enter. Okay, that's how you do it. Then you have multiplication and division occurring together. So
the rules of board mass apply here, right? So what will happen is that division will happen first, right? And then multiplication will happen, and then subtraction, and then addition, right? So that is the order of things. So division takes priority over everything else. That's how it is when we write it on a piece of paper, and that's how it is here. So here the output should be 3 times 2 is 6 minus 1 divided by 4. 1 divided by 4 will happen first, which is 0.25. So 6 minus 0.25, right? So first division happens, then multiplication happens, and then subtraction happens. So 6 minus 0.25 should be 5.75. Let's check, that is also correct, right? Similarly, if you want to specify here, now if you genuinely don't want to do this 3 times 2 first minus 1 by 4, actually what you want to do is you want to do 2 minus 1 by 4 and then multiply it by 3, right? So you apply brackets around this. So how will this work? First this will take place. So 3 minus 1 by 4 is 1.75 times 3 would be equal to 5.25. Okay, so that is how it works. So you can also use brackets to make it more intuitive. Okay, so that is how it works. The basic arithmetic operations work perfectly in R, right? Okay, so that was all about basic numerical operations. Now let's see some formats of output. So if I show you, if you do a division by 0, 5 by 0 let's say, or 10 by 0, whatever, right? This will give you infinity ideally, right? Because dividing anything by 0 gives you infinity, so we'll get the output as INF. Okay, similarly, if you do a 0 by 0 form, then you will get NaN as the output, which is not a number. 0 by 0 is undefined, it's not a number, right? So that is, these are some things I want you to know. Also, if you do a square root of a negative number, let's see. So square root you can execute through a function that is called as sqrt. Okay, you need to write sqrt, and then you take a square root of any negative number. What do you get? Again, you get NaN, because again this is not a number, this is an imaginary number, right? So it gives negative NaN, right? Similarly, square root of minus 10 will also give you NaN, right? So that is your output. Okay, and it's also giving a warning that because of this number you have an NaN produced, right? So that is the idea. Similarly, you have other functions, right? One function is logarithmic function, so you have log, right? Now, as soon as I type log, you will see that some information about the log function pops up, right? It tells you like what is it that you want to put in the first argument, what is it that you want to put in the second argument. So this is how functions in R work, right? Where you have to put multiple parameters or arguments into it in order to get the answer. Okay, so if you want to understand any function well, or you want to understand what are its parameters, how does it work, what you can do is you can seek help on it. To seek help on any function, you can type it with question mark, right? When you type it with a question mark in the help section, you will just get all the information about it, right? So this is your logarithm and exponential section of the help, and here it's telling you about multiple functions. What you can look at is the usage of the log function. So usage of the log function, the first argument is x, and the base argument by default, this is the default value which is written with the equal to. You can obviously change it, but this is the default value, that's what it's telling you. So the default value is exponential at 1, that is e. So by default we are looking at ln, that is natural log. Okay, if you want to look at log base 10, you can also write it as log b, okay, or log 10. Log 10 means log base 10, log 2 means log base 2. Okay, so that is how you can use it. And log 1p gives you log of 1 plus x. Okay, accurately also for x where modulus x is less than 1. So if you want to get log of 1 plus x, you can use log LP. Uh, log 1p x, right? So that is one way to use this function. So I'll see a couple of log examples. So log, by default, if you write log and you take a log of exponential of 1, again this is the other function, exponential. If you want to put any number to the power of e that's a constant, you can write it as exponential. So log of e should be what? Should be 1. So I am getting my answer as 1, right? And if I want to type log of exponential function squared or log of e square, I'll get 2, right? Similarly, if you want to write log base 10 of, let's say, 100, you can write it like that, okay? Log 10, 100. So this should give me 2, right? Another way you can write this as log 100, you're taking a log of 100, but what is the base? The base is 10. You can either write base is equal to 10, right, this way, or you can say log 100 10. The second argument, see, it takes the arguments in this order, so you have to provide it in this order, right? The second argument is the base. The first argument is the value of which you are taking a log, right? So either you use these functions, which is log 10, log 2 sort of functions where you write the base first, right? Or if you're using the log function, then you have to type the base afterwards inside the bracket. Everything is told by this help section. So you just need to read this help section in order to understand how to use these functions, right? So all of these will give you the same result, that is 2, right? So log 10 100 is 2, log 100 base 10 is also 2, and log 110 is also 2, right? Because the second argument is always the base, right? So that is how you can write it. And by default, if you take a log of anything without typing a base, the default value of the base is exponential function. So you are getting 0.6931472, which is log base E2, right? This is the natural log, this is ln, okay? So that is why you get this result, okay? So that is something. Then in the exponential function itself, it has given you exponential m1, which is just exponential of x minus 1, right? So if you take this exponential of, let's say, exponential of 2, so you can do exponential m1 2, which will give you exponential of 2 minus 1. Yeah, so it's giving you 6.389056. That means that your exponential of 2 should be 7.389056, right? 7.389056, and when you do a minus 1, you get 6.389056, right? So that's how this function works, okay? So these were a bunch of things. Then you also have your trigonometric functions, right? So trigonometric functions, you can write sine, cos, tan, so on and so forth. So you need to write the argument in these cases in radian and not degrees, okay? So if I just check the help of sine, okay, if I check the help of sine, you will see it's giving me all the trigonometric functions, so sine x, cos x, tan x, and the usage, if you see the usage, it's given in terms of radian, right? All of these are given in terms of radian, not degree, right? It's saying these functions give the obvious trigonometric functions. They respectively compute the cosine, sine, tangent, arc, cosine, so on and so forth, and the two argument arc, tangent, okay? So here again, everything is in terms of radian and not degrees, okay? They're numbers. So if I do sine, if I want to get sine 90, so then I'll have to do sine pi by 2, okay? If you remember the value of sine pi by 2, you will get that is 1, okay? Similarly, your sine 0, should be 0. Okay, sine pi by 4 is 1 upon root 2. Okay, so pi by 4 is 1 over root 2. Okay, sine 2 is this number. Okay, so this is how you can calculate your trigonometric function. Similarly, you can do for cos and tan. So if I want to do this for cos, I can just paste the same functions. What I'll do is I'll do a find and replace. So edit, find and replace. So in R, apparently find and replace does not work while you have a selection. So you'll have to first click on find and replace. So edit and go to find and replace. You can also use this shortcut to access find and replace, right? In my case, because I'm using a Mac, the shortcut is Command Shift J. Okay, but in Windows it will be different. So see what the shortcut is. It would be mentioned here, and just use that shortcut instead of clicking find and replace every time. That will be faster. Okay, so what I'll do is I'll now do a find and replace on this. Okay, without selecting anything. So this find and replace window pops up, right? This find and replace window without selecting anything. If you select something, it doesn't pop up apparently. Let's see. Yeah, it's not popping up. Okay, so in my case, Command Shift J. In your case, whatever the Windows shortcut is, if you're using Windows, you select the entire text and you say in selection. So I want to do the replacement in the selection, and I want to replace sine with cos. Okay, and I want to replace all. I can replace one by one, all replace all. I want to replace all the signs with cos. Okay, so I'll do all. Okay, all 3 occurrences replaced, and these are my functions. And now if I run them, see, all of them pop up. Cos pi by 2 is this number. Okay, cos 0 is 1. Okay, and cos pi by 4 is this number, which is same as sine pi by 4. Okay, so that's how you can, this number is not coming out to be 0. Actually cos pi by 2 should be 0, but this is a very, very small number. You see, it's exponential to the power of minus 17, right? So that's a very, very small number. That's almost 0. Okay, that is why R gives you this approximate value through some numerical methods. That's why it's not able to give 0 here. It gives this very small number, which is approximately 0. Okay, so that is what you have. Then next thing I want to talk about are your inverse trigonometric function. Okay, so for inverse trigonometry, you can use a sine, a cos, a tan, these functions, a tan, a cos. Okay, so then if I want to see what is a sine 0, this should be 0, right? This comes out to be 0. What is a cos 1? That is also 0. What is a tan 1? That should be so tan 45 is 1, right? So that would be pi by 4, right? So that is 0.7853. What is pi by 4? So pi by 4 is again the same number, right? So you see these functions, inverse trigonometric functions, can also be used directly. Okay, after this I want to talk about factorial and combination. So if you remember permutation and combination, we used to have something called factorial and combination. So for factorial, you are basically taking the product of n natural numbers, right? That is what factorial is. So 3 factorial should be 3 times 2 times 1, right? That would be 6. So this is coming out correctly. Then 5 factorial would be 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20, 20 times 6 is 120. This should come out to be 120. This is how you calculate your factorial. For combination, you use choose, okay? And the arguments are n in case for nck. So if I want to do 3c1, I do choose 3, 1. And that will come out to be 3. Choose 3, 2. That will come out to be 3. Choose 3, 5, it should give me an error. Okay, it's giving 0. Okay, 7. You can't choose a bigger number, it gives 0. If I do a 7c3, It'll give me an answer. That's 35. Okay. So that is how you calculate your factorials and combinations. Okay. Okay. So the next thing I want to get into is the various functions you have in terms of getting help. Okay. So first thing that we have discussed is, in order to get help on any function, the broad help, you can actually do question mark and then write whatever the name of the function is. So for example, I can do question mark choose and then run it, right? And then it will give me the help for choose, right? So that's choose n comma k, l choose factorial, and I can read about all of these, right? So that's how you get your help. There's another way to do it, which is help, and then you write the function, okay, and then that also does the same thing. There is no difference between these two. So these two are identical functions. uh, After this, you have a bunch of other functions. If you just want to check the arguments of a certain function, let's say I just want to know what are the arguments which go into choose, so you can just do args and then choose, right? uh, and then that just tells you, okay, you put two arguments n and k, right? Similarly, you can get the args for log, okay? So args for log, what would be the arguments? Arguments basically mean the parameter which go into the function, okay? So it's the function, you put in the value x, and base is, there's a default value to the base, but you can obviously change the base, right? So this is what it gives you. Now you have another way to search or look for functions, right? If you want to like find functions with a certain string in their name, right? So there's a function called as approps. Okay, approps just searches the R's help section and tries to help you find functions which have this in this string in their name. String means any sort of phrase or a bunch of letters. So what are the functions with log in their name? Okay, let me, okay, I made some mistake here. APRO, yeah, this is apropos. Yes. So all of these functions have log in their name, and then the one that we're looking for, log 10, log 2, logic, right? Just log would also be here. All of the functions, yeah. See, log is also here. Log 1p is here. Log b is here, right? So you have all of these functions, right? So you can actually look through all the default R functions with this string in their name by using apropos, right? So that is one. And if you just want to see like how to run a particular function, you just want to see examples, so you can do example and then see how you run log or choose, right? So if I go for example, it would just give me the example of how to use log. So it just shows here log exponential 3 would just give you 3, because the default base is already the exponential constant, right? Log 10 1e7, right? That just gives you 7, right? Because when I write 1e7 in R, all I'm saying is 1 multiplied with 10 to the power of 7. Okay, this is the way to write 1 multiplied with 10 to the power of 7. If you even want to check it, you can actually see if this is equal to some other number by just writing this equal to 10 to the power of 7. So 7 zeros, right? 1 2 3 4 5 6 7, right? So this should give you, oh, I should put double equal to's. Yes, this will check if this is true or not. See, this is true, right? This is how you can check equality of two numbers, by putting double equal to sign between them to compare them, right? So 1e7 is same as 10 to the power of 7. That is 7 zeros after 1, right? So now if you take a log 10 of it, right, that would obviously give you 7, right? Because that's what you're checking, what power of 10 is this number, right? So that's the 7th power. Now similarly, if you want to write 5 into 10 to the power of 7, you can write that as 5e7. Okay, so again, if you check, these two are equal by putting a double equal to sign between these two numbers, you will realize again this is true. Okay, so that's how you work with the arithmetic and numerical functions. So I've taught you a bunch of things there. Now see, as in mathematics, so in R, algebra becomes very important, right? You need to be able to assign values to a variable. Okay, if you would remember, in high school, mathematics changed completely after algebra was introduced, right? So before algebra, you had a whole bunch of math which was to deal with numerical problems, right? There were numerical methods, right? But if I am to variabilize my problems, if I want to solve it for any value of a given variable, right, I need algebra, right? So that is where we start working with objects. Okay, objects are any, you can think of them as a placeholder or a bucket in which any value can be stored. Now there are various data types in R, and we'll get to data types, but any data type can be stored in a placeholder, which is a variable or an object. Okay, so that is what we are starting with now. Let's start with the simple example of storing numbers into objects. So how do you do that, right? If I want to create this object A and I want to store the value 5 in this, I can do it this way. So 5 gets stored into A. This is a very new, intuitive sort of syntax, right? 5 is literally through an arrow going into A. So if you run this, you get this object A, whose value is now 5. If you check what is the value of A, you will get 5, right? And it also shows in this environment tab on the right, and it says A has a value of 5, right? There's also X, which has a certain value, but let's just ignore that for now. We might have that from earlier, right? But all you need to focus on is A. A has a value 5, right? Another way of assigning values to objects is by using the equal to sign, which is also another way that works. Okay, double equal to is used to compare, right? So this would give you true or false, but a single equal to can be used to assign values. So let's say I want B to be 2. Okay, so if I run this, now B is 2, you would see B has a value 2, right? So now if I want to multiply A and B and store that in the result variable, so result is equal to A into B, right? So this becomes your result, and see, result is 10, and you can actually print the result, or you can just say result and it will give you this result, right? So result is 10, right? You could also have done result and assigned it A times B. That also works. This is equivalent. So this symbol of arrow and this equal to, they are equivalent. Okay, so this is how your objects in R work, right? So now that's how you make objects. You also might want to delete objects. So how do you delete objects, right? So in order to delete objects, you use this. If you want to delete all of them, what you can do is you can click on this, this broomstick, and that would delete all the objects, right? But if we want to delete a few objects, let's say I want to delete my result, so use the rm function. Okay, rm is able to delete objects. So I want to remove result. Okay, so when I remove result gets removed from here, right? So that is the way to do it. If you want to remove multiple objects, you can remove 2 or 3 or 5 objects together. So if I want to remove A and B, I will say remove rm A comma B, right? And then both of them got removed. Okay, if I want to remove X now, I can remove X as well. The environment became empty. This whole thing you could have just done with one click on the broomstick. Okay, now what is the naming requirement for an object? Let's talk about that, or a variable. See, there are a bunch of rules you need to use, like you can't assign values into 5 because that's already a number, right? And you can't use special characters. If you use 5 star, or you say A5 star. Okay, A5 is a valid object. I can use A5, but if I do A5 star, this won't work. Okay, if I want to see, this has already given me an error. This is an unexpected token because after star I wasn't expecting this. Hash is also not allowed because hash makes it a comment. Okay, so what are the naming rules? Okay, let's talk about them quickly. So naming rules are here, right? The name of the object must start with a letter. So the first character should be a letter. Second, it can contain letters, numbers, underscores, and periods. These are the 4 characters which are allowed. Okay. So you can have an object which is Romit underscore actuarial guy underscore 218 period, right? And in this you can assign the value 218, right? So if you want to do this, see, so this objective is created and I have assigned this value. So all of these are valid characters and it has started with a letter. Okay, it cannot contain spaces, and they are case sensitive, right? So this variable, right, and this variable with the r being capital would be different variables, right? These two are different variables, right? So they are separate. Okay, so this is case sensitive. So yeah, that's all I wanted to tell you. If you have deleted an object, you won't be able to use it and you will get an error, object A not found, right? So for example, I've removed these A and B now. So if I do A times B, it will give me errors, object A not found, because it just looked at the first object and that even wasn't there. So it didn't even bother looking at B, right? So that is all for what I wanted to discuss in this lecture. Now I want to discuss 1 or 2 examples covering some of these concepts so that you have a good hold on these concepts. Okay, so now I want to look at 2 very simple coding questions, okay, which would cover all the concepts that we have discussed here, or a fair bit of concepts. The first one is an annuity calculator. So an annuity is certain, pays 1 at the end of each year for n years. The value of this annuity is given by the formula. An at the interest rate of I is 1 minus 1 plus I to the power of minus n divided by I. You would be very, very familiar with this formula if you have done the subject CM1. But even if you have not done it, no problem. Okay, you don't need to worry a lot about it. You don't need that knowledge for this question because this formula is given. Annuity value just tells you what is the present value of this stream of payment of 1, which is payable at the end of every year for n years, right? So if I'm paying £1 or ₹1 at the end of every year for 10 years, how much would that be worth today? So that's what we are trying to calculate. But again, from the perspective of this question, you don't need that knowledge in order to solve this. Okay. So what are the requirements? Write an R script that creates object n and I for the term and interest rate respectively. Set n to 20 years and I to 5%. Then they want us to calculate the value of annuity using the formula above. They want us to store the result in an object called annuity value, and they want us to print the final result. These are the things that are required. Okay. So first, let's just begin by creating a new R script. Okay. And calling it annuity calculator. So what I'll do is I'll save it as annuity calculator.r. And I would put it in my R scripts folder. So where is that? R programming lessons, and I will just save that. Okay, so this calculator is made. Now let's step by step go over what do they want us to do. The first part is create objects n and I for term and interest rate. Set n to 20 years and I to 5%. So I want n to be 20 years and I to be 5%. You can also use the equal to sign. That is completely up to you. Okay, I'm going to use equal to sign for assigning I, and the arrow sign for assigning n. Okay, so this was the first step. The second one is calculate the value of annuity using the formula above. Okay, so now I am going to write that formula. So that was 1 minus 1 plus I to the power of minus n divided by I. Okay, so this is my formula, and this formula they want us to store it in annuity value. Annuity value. Okay, so my annuity value is this, and then they want us to print this annuity value. Okay, so this is what I need to do. Now let's just run the entire script. Okay, so n was assigned, I was assigned, annuity value was calculated, and the annuity value was printed. Let me verify the answer. So the answer is correct. So this is how you do it. But in this, when someone reads your script, they won't be able to understand what you have done. So you need comments. Comments are very important. So the first thing we have done is assigning variables. Okay. Second thing we have done is defining annuity value. Even in your exam, it's very important to have comments so that the examiner is able to understand what you're trying to do. Okay, and then you have done printing result. So that is what you've done, and now we can save this script by pressing Command S or Control S. Once you press Command S or Control S, this tab for this particular script would become black, right? And that star will go away, that asterisk would go away, right? So now this is a saved script and we have run it as well. So that is your first one, right? For the next question, I will make a new file, new R script. So let's look at what the next question is. That is the conditional premium calculator. Okay, what is the puzzle statement? An insurance premium is calculated using a base premium of 500. There are two additional risk loading. The first one is a smoker loading of 150 and an age loading of 100 if the person is over 60 years old, right? So if someone is has an age greater than 60, then this age loading comes into picture. 100 is the value of that if the person is 60 over 60-year-old, and if they are a smoker, they have to pay 150 extra. So if someone, let's say, is 65 years old and is a smoker, right, for them 100 would be added because they are more than 60 years old, so that would become 600, and they are a smoker, so 150 would be added, so that would become 750, right? These loadings are cumulative and you are given two variables. So firstly, we are given variables age and is smoker, right? So what I'll start with is, I'll start with a new script. You can also use Command Shift N or whatever the corresponding window shortcut is. I believe it should be Control N, but you can check. Okay, so Command Shift N, new script is here. I just paste these variables and I say assigning variables. Okay, so this bit is done. Variables are assigned. Now, what do they want us to do? Write an R script to calculate the final premium in a single line of code without using if all else statements. We have not even learned if and else statements in R. We'll learn that eventually, so we'll do that without. Your calculation should correctly handle any combination of age and is smoker values. Okay, so let's see how do we do this. Okay, see. We want to do it in one line of code. So the final premium will be equal to something, right? Now, there are two conditions here. One condition is age is greater than 60. So this is one variable, right? So let me make this one variable. And if you see, if I assign age as this, okay, let me run this piece of code. So when you assign age as 65 and is smoker, it's true, and you check if age is greater than 60, you will get true. So now automatically whenever age is greater than 60, this would be true. So I have final premium is equal to true now here. See, final premium has come out to be true. Okay, but that's not what we want the final premium to be. what do we want the final premium to be? We want it to be base premium plus, so let me also make base premium as a variable, premium, right? And base premium is what? Base premium is 500. Okay, so I want it to be base premium plus 60, age is greater than 60. If this is true, right, then this would be multiplied with, or I would want to add a value of 100. Okay, so I'll multiply it with 100. See, whenever it is true, the value of true is 1 and the value of false is 0. So you can always treat true as 1. Okay, in fact, if you will try to convert, okay, let me show you this. Okay, when you take true plus true, if you will add them up, you will get a value of 2. That means true is treated as 1. Okay, the value of true is in fact 1 and the value of false is always 0. So true plus false is still 2. Okay, so this true is 1. So it will be 1 if it is true, 0 if it is false, right? That is how it will work. So whenever this is 1, I want to add 100 plus, okay, what is the other thing I want to do? If is smoker is true, is smoker is already a variable which is true here. So if is smoker is true, I want to multiply another 150, right? This will give me my final premium, right? So that is how it works, right? You can treat true and false as 1 and 0. Okay, so now if I check, my final premium should actually be 750. Base premium is not defined. First I need to define base premium. So I run these two lines of code. See, final premium has come out to be 750. Okay, if you want to check it for another case, okay, so this was calculating final premium, right? And if you want to check for another case, let's do checking another case. Okay, now you can take any value of age and smoker status and actually get the premium using this final premium formula. Okay, let me also print the result. Printing result. Okay, this is my third comment. So this will be print what? I want to print the final premium. So let me just copy this and just paste it. Okay, so this actually gives me my result 750. Now I want to check another case. If I make age as 59, so the premium, this 100 should not be added, but smoker is true. So now the premium will come out to be 500 plus 150, that is 650, right? So now if I check, what will it come out to be? So I'll have to run this part again. First I'll run this. Okay, so I've changed the age and is smoker value. Age is now 59. Is smoker is true. Okay, I should get 650 if I run these two lines. Yes, I've gotten 650, right? Similarly, if you make this false, then you will get 500. Okay, if you run this, you have to run these two lines again, you get 500. Okay, so that's how it works. To run it every time, select it, press command enter or control enter if you're on Windows. Okay, so that's how it works. Now I will save this. In order to save this, I'll call this premium calculator. Okay, and this I will just save. Okay, so that's all for this lecture. We'll talk about more in the next one. Thank you.